Okay, so in this video we'll see how to do the CC amplifier experiment. So basically, as soon as you get the question, you have to do three things. First thing is you have to write the aim. Aim will already be given. So you need to know the formulas. You need to know this formula, that is amplification is equal to V output by V input, right? And then you have to draw this table, basically frequency, voltage output and gain. Okay, so now let's understand what all these terms are when it comes to the apparatus. And you have to also draw the circuit diagram, right? You'll see the circuit diagram and do the connections. And if possible, you draw the sample graph. First of all, the apparatus we require is the module, amplifier module, and we'll need a signal generator, and we'll need some wires to do the connections. So basically what we'll do to start with, we'll connect the signal generator. So this is the signal generator. So signal generator's output, we'll connect it to this voltmeter. So this display you see here is nothing but a voltmeter. Okay, and then switch it on. Basically now we are measuring the input signal's voltage, right? This is the input signal. Without doing any connections, we will first of all measure its voltage here. Now once we switch this on, what we have to do is, initially we have to take a frequency of 1 kilohertz. Okay, we take a connection of 1 kilohertz, and with 1 kilohertz the corresponding voltage has to be 1 volt. Okay, if it's not 1 volt, in case it's not 1 volt, you have to change the amplitude, right? Once you change the amplitude, you see the voltage is changing, right? When you change the amplitude, so you use this amplitude dial and change the voltage to exactly 1 volt. So these values are written in the book, right? 1 kilohertz and 1 volt is written in the book. Okay. Now then next step is, what you do is you do the connections. Now once you know that your input voltage is 1 volt for a 1 kilohertz frequency signal, you do the connections. So how do you do the connections? You can switch your amplifier module off, okay, then do the connection. Okay, so if you see the circuit diagram here, you can see that the RE, right? RE says 8.2 ohms, right? RE here, it says it's 5.6 kilo ohms. Here it's 8.2 ohms. So since there is no 8.2 here, you can just leave this the way it is, because 5.6 is the closest to 8.2, or else you can go a step ahead and connect this to 10K, but it's not necessary. Okay. Second thing is, you can see that the R2, okay, R2 is given as 33 kilo ohms. So R2 33 kilo ohms is already connected. Okay, so there is already a resistor here that is 33 kilo ohms. Okay, and here you can see R1 is 56 kilo ohms. That resistor is also already connected. Okay, now next you can see that here you see that there is a resistor, right? This resistor RC, but in the circuit diagram you see that there is no resistor. It means what? This resistor has to be removed. How do you remove the resistor? You take a wire and short it. Okay, when you take a wire and short it, basically what happens is the current passes through this wire, because it's the least resistance path. Okay, it won't go through the resistor. Okay, that's the first connection you make. Okay, next R1 is done, R2 is done, RE is done, then C2 is also done, right? C2 is 1 microfarad, and here it is 0.1 microfarad, but actually apparently it doesn't matter. Okay, you can just leave it the way it is. Next, what you do is you have to give this circuit a potential, right? How do you do it? So we have a voltage input here. So voltage has to be input to the circuit. So how do you do that? You take a wire from the voltage and connect it to the input. Okay, so you can connect it somewhere here. This is where the input voltage is. So this point and this point is, yeah,
2 plus 10.
Yeah. So actually here or here, it actually doesn't matter. Okay, because these are all the same wire. Okay, same wire. So it doesn't matter where you connect it. So for simplicity, let's connect it where plus 12 is given, and minus 12, as you all guessed, minus 12 has to be connected to the ground. Okay, so for simplicity's sake, we'll connect it to this ground. All these ports here are grounds. Okay, you can connect it anywhere, it doesn't matter. Okay, so now you have input your voltage. Next, this capacitor C1 is already connected, R1 is done, R2 is done, these grounds are already connected, RE is done. Now what you have to do? You have to give it an input and give it an input and take the output, right? So since let's connect the input here. So as I said, all these are equivalent, doesn't matter which ground you connect it to. Okay, these are all grounds. Now what you do is, since this is our signal input, I'm connecting the positive to positive, okay, and the negative to negative. Now I have given the input, okay, I have given the input from the signal generator. Now I'll take the output. Which output will I take? After the capacitor, you see that for CC amplifier you have CC output. You take the CC output and connect it to the positive, and the negative to the ground. This is the ground. You connect the negative to the ground. Okay. So next, what you have to do is you switch on your module. Once you switch on your module, you have the table frequency, output voltage, that is this one, frequency that is given here, okay, and then gain. Gain is nothing but V out by V in. What is the V in we took? Initially we measured a voltage, no? That voltage, V input voltage was what? 1 volts, right? 1 volt. So basically output voltage and gain will be almost the same. So you plot you take the values for a range from 10 Hertz to 1000 kHz, 1000 kilohertz. Okay. So let me take the readings. So basically, once you use this dial to change the frequency. Okay. Once it reaches the end, you cannot increase it more than 100 Hertz here. So what you do, you reduce the dial and you press this button. It goes to the next decimal, right? It goes to the next decimal. Now, when you do this, so it became 100 Hertz. See, when 100 Hertz comes here, 100 Hertz comes to this side of the dial. You increase it, it goes to 1 kilohertz. If you want to increase more than 1 kilohertz, you reduce it to 0, and the base will only become 1 kilohertz. The 1 kilohertz has come here. Did you understand? It's basically you are transposing the range. Okay, you're transposing the range. So you basically take the in output there. You have to measure the output there. You have to plot the output from 10 Hertz to 1000 kilohertz. Okay, that's what you do. Basically 10 Hertz, 20 Hertz, 30 Hertz. You see the graph. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. When you reach 100, you don't go to 110. You go to 200, 300, 400, 500, 600, 700, 800, 900. Basically, you're transposing the decimal place. Okay. Till here, the decimal place was 10. From here, it became 100. When you reach 1000, it becomes 1000. Why do you do this? If you take a normal graph and plot this, you know that 10 to 1000 kilohertz, it will be a really big graph. Okay. Since most of the values for us is like literally constant, we can use a log graph. This first 0, 1, 2, 3, no? That is your tens. From here, it become 100, 200, 300, 400, 500. It become 1000. Then it will become 1000, 2000, 3000, 4000. Nature of the values is, for that, you can use a log graph. Okay. So now, you took the values, you plotted them on the log graph. Next, what you have to do is, you have to calculate its bandwidth. How do you calculate the bandwidth? Maximum amplitude, you get a line, right? You get a straight value. So basically, here in the graph, you can see that for a long range, right? From 1000 Hertz to around 100 kilohertz. For this big range, you are getting a constant value. That constant value is nothing but this value on the graph. Okay, that is the maximum gain graph. Now what you do is you draw this line and see what the value is. Okay, so apparently the value is 1 here. Okay, that is the maximum amplitude or maximum gain. Now we take that maximum gain and divide it by root 2. When you divide it by root 2, you will get a value. You draw a line corresponding to that A max by root 2. Okay, you draw a line corresponding to A max by root 2. It will intersect this graph at 2 points. Okay, and draw those 2 points, plot those 2 points on this graph. Okay, so corresponding to the higher frequency where it cuts, you take that frequency. Lower frequency, you take that frequency, and higher minus lower is the bandwidth. Higher frequency where it intersects minus lower frequency where it intersects, it's the bandwidth. Okay, so in the final result, you will write the bandwidth. Okay, that's the experiment.